Yeah. So hello everyone. My name is Deepak Singh and I'm a software engineer. So today what we'll see, we will learn this database. Like what are the things we can perform with the database and what exactly it is, right? So let's see what is database. Okay. So if someone asks like what is database and if you heard this term like database, then what are the first thing that comes to your mind? And what are different things which we can perform with this database, right? So basically, database like where we store data, right? And let's say you are building an application and where you want to store some data, right? Let's say you are building an a kind of a school application, so you want to store data of teachers, faculties or anything. So what you will do? You need a database, right? Where you have to you want to store this data, right? So yeah, so we need something where we can store data in the same way. If we want to store it in database, then this is the thing which we can also perform, right? Because it is not like okay, we are only storing data. We need to create data, right? We need to sometimes we also need to read data, right? Because if we are having a database, we need to perform at least this four operation, right? If we are not able to perform a read or update or delete, then it doesn't make any sense to have a database, right? So to create data, to read data, to update data, let's say any typo happens or anything happens, you want to update, you can update, you can delete. Okay, these are basic things which we can do with database, right? So what else we can do? Let's say you wanna find it employee where his name is called Deepak Singh, right? So you can find data with a certain filtration, right? While filtering data, like okay, with the name this one, email this one, or which marks is maximum, which marks is minimum, right? So you can perform all this operation that is called query. So with database, this is the minimum thing, minimum requirement. Up to advanced level, we have so many things: creating replica, creating data sharding, so many things. But there's a basic thing which we should know, we should do with the database, right? So in real world, like we have two different type of database. So basically what they are SQL and they are NoSQL. No, see what is SQL? It's a structured query language. Means whatever data you are going to store, this should be structured, right? Let's say, yeah, inside this SQL, we are having a MySQL, very famous, and then we have a PostgreSQL. There also is also very famous, and yeah, and in NoSQL we have MongoDB. This is a very famous NoSQL database written on C++. So it's very fast, highly scalable. You don't have to do with all this stuff. Now coming to SQL, later we will see it, like what are the difference. Now we have a SQL versus NoSQL. In a which scenario we have to opt with the SQL, or in which scenario we have to choose MongoDB. We will see. So in broader way, there are many more. I don't remember their name. You can just go on Google, but they are in a in our country or in a world. These are all very famous, right? So we are mainly focused on MongoDB. Like what is this? Okay, so let's come to the difference. Okay, what is the difference between SQL? Difference, yeah, difference between SQL and NoSQL, right? So let's start with SQL here and NoSQL here. Basically, when the data is like what kind of data you are going to store. Like let's say you are going to store an employee, right? It should have a name field. Let's say let's say it should have a name field, email field. You are very much sure that here it will be name field, password field, and email field. There are only three fields which I have to save, and name will be a string, and email also be a type of kind of a string or character you will say, and a password will be also a string data types, like what they are going to be. You are pretty sure like okay, this will be okay. So you can go with the kind of SQL because they are already secured, right? You are very much aware about this structured data, right? So you can go with the SQL. Like if we'll not go in a cap theorem or Escher theorem in kind of difference thing. So first thing, if your data is structured, you can go with the SQL. ठीक है यार. Okay. Second thing, कि what else? If come to NoSQL, it is like second thing is कि, since you are it is you are, it will store only, it will store only no structured data. So we need to define a schema. We need to define a schema before before saving into database. Okay, like how what is schema? Basically schema is कि ठीक है यार, you are defining a structure like ठीक है, how you are going to store this field, right? How this field will be, how many fields there are. Let's say there are name, email, there are three fields, and what data type there will be. ठीक है. So you have to define the schema. It is very kind of mandatory thing. It is very required. ठीक है. Once you will define the schema, then only you are going to store data, right? Without defining schema, you cannot store database data, right? Third thing is it is good for, it is RDBMS, right? Relation database management. Like here you can add, let's say now, before going to this RDBMS, let's learn what is what else you can do with the database. You can, let's say you are having a you wanted to store data of your school, right? So inside a school you can have so many different collections, right? So many different many different tables or collections. Like no see, you you may have like it here. There will be, for example, let's say for example you may have a teacher table, teacher, or a faculty table, faculty or table, right? So you will store only data of faculties, right? What are they are, like class 9 faculties, 10 faculties, all this thing. You may have of a student table, where you will only store data of students, right? So we need inside a database we need to have certain tables, as well as if we talk about the SQL, we will have tables. Okay, if we talk about the NoSQL, we'll have collections. Okay, so yeah, so basically SQL store data in a table format. So we may have so many tables, right? Now, if you are having so many tables, so you must know how to create a connection between tables, how to create connection or uh, connection, not sorry, join. How you can join different table and perform action, right? Perform action. Yeah. Means if there are two tables, it at later at any certain time, you maybe any requirement came like okay, I need faculty as well as student. No, any requirement came where you have to join this table, right? So how will you do it? So you should know how to do it. And we have left join, inner join, so many joins in a SQL, in a yeah. So we need to do these things, right? So yeah, we will basically SQL, it is store data in a table format, right? So inside the table we will have this all this declared field, let's say name, email and password, and where to store it data. Okay, so it is very good for if we have so many you have so many joins, like let's say you have 10 10 or 12 different tables, and you want to join each table, then it will be not slow, or it will be good, it will be easy to for in a SQL database, while it will be little tough for NoSQL. Okay, now come to kind of what else we can have. Yeah, so yeah, in terms of scaling, it is good for horizontal scaling. Mm, Horizontal scaling. No, it's good for vertical scaling. I'm little bit confused. Basically, the difference between vertical scaling and horizontal scaling is one where you can create a multiple instance, and one where you can increase the CPU, you can increase the RAM, you can increase the data, increase the things. Let's say you are having a database of let's say 8 GB of RAM, and 1 TB of memory. Let's say. Now, if you wanted to, your query is taking more time, you wanted to scale it. Okay, ठीक है, I just need data a very quicker format, in a very less time. So what you can do with the vertical scaling, what the in where you can just increase it to 16 GB RAM of 16 GB RAM and make it 4 TB of hard, 4 TB of memory, and do these things. So basically, in SQL we can do these things. We can it is easily in SQL where we can you know do vertical scaling. We can increase the size and all this stuff. And what else? It follow the cap theorem. What does cap theorem means is कि, let's say at a certain point, certain moment, read and update is happening. Read and update is happening. So what uh, what what SQL do? It will put this task in a queue. In a queue. So it may give you a result in a little. It will take little more time to give you a result, but it will give you accurate result, right? Because it will do it will do one task at a time. It will do one task at a time, right? This is what SQL is. It will do one one task at a time. Okay. So let's say if the read comes first, then it will first read and then update. Let's say update comes first, it will first update the data, same data, and then read. Okay. So it will do one task at a time. So it keep putting all this operations in a queue and then start working on it. So basically, let's say in case of transactions data, transactions data, where 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 let's say where time doesn't matter for you. Let's say you are paying someone using phone pay or google pay. They are, let's say if I'm paying someone to 10,000 to 20,000 or more than that, then it may take 2 seconds or 3 seconds or 4 seconds. You will wait, right? Because it is kind of you don't want to play with data. ठीक है, it may take time for you. It's okay for you, right? So where time may not matter, may not that much matter, but accuracy matter. But accuracy matter. ठीक है, if I send someone to 10,000, then it should get credited with 10,000, not 9,000, not 8,000, right? But accurate data. So you to go for the SQL database, right? Because it follow cap theorem. And moreover, they try to, yeah. What else we can have a difference? Take a string data, and then we should define the schema. It is a relation database, so we store data in the tables, scalings, cap theorem. Later on, we'll see if we miss any point. In NoSQL, it's like it is like schema less or schema less or dynamic in schema, or dynamic schema. What does it mean? It means whatever you wanna store, you can store. Like whatever you want to store, man. Whatever you want to store, whatever you wanna store, it will store it. It will store it. Okay, now let's say you're not very much sure what data you're going to store. Sometimes you will just store name and email. Sometimes you will store with email and password. Sometimes you will store age and name. You're not sure, man, what data you're going to store. Sometimes name maybe a string. I'm just don't go with this field. I'm just telling you. Sometimes email can be a number. Sometimes a password can be a boolean value. Maybe I'm just giving you an example. And here sometimes email can be anything, an array. So you are not very much sure, man, what data you're going to store. Then you can opt with the NoSQL. Okay. Now, since it will give you that much flexible. It is very flexible about the schema. Data about data which you are right? So very flexible, like whatever you want to store, it's a store it, man. Okay. Now you can store that thing also, although if since it is very flexible, since it is very flexible, then you can store, you can make this schema as a schema based also. Okay, yeah, it's up to you, like how you wanna store. You can design a schema. It's okay for us. It's okay for NoSQL. If you not design a schema, then also it's okay for NoSQL. Okay. Now use cases. It store data in collections format, collection and yeah, document document. It's like it is a document database where whatever documents, whatever things you want to store, just store it JSON format, JSON data, whatever. Okay. They store data in the collections. You may have different collections. Let's say you may have student collection, where you may have faculty collection. You may have uh, you know whatever books collection, whatever. And inside this student collection, you store data in a document format. Okay, let's say first document, and let's say second document, and third document. Yeah. And success, what else we can, so it follow the AC property. Later we'll discuss what this AC property is. It will try to make you a more availability time, right? It will it will it is good for heavy read and heavy write. It is good for it is good for heavy read, heavy heavy insert. Let's say you want to insert 10,000 data in millisecond, it will do that thing. Heavy write, heavy write or heavy insert, insert, let's say 10,000 data in a millisecond, it will do that thing. But sometime if there is concurrent request, means 10,000 document in a millisecond, document in a millisecond. So let's say sometime, what is concurrent mean is कि let's say at 10:15, 10:15, uh, uh, 45 millisecond, 45 seconds, there is some request came like, okay, we I want to insert this, I want to update this document, update update a document, update a document, and at the same time there is an kind of read happen, document read happen. Okay, it try to do, it try to execute both thing in a parallel way. So you might get mismatched data at a moment, right? So that's why we do not prefer this all these things for the for transaction data, for the transactions data. We do not prefer, right? Okay. So yeah, we not prefer MongoDB. It is for let's say you are building an a kind of banking system. So it is good for storing the logs, whatever request you came, whatever request you can store, whatever response you got, your API gets, right? So you can store that thing. And moreover, yeah, what else we can, yeah, regarding scalability, it is good for horizontal scaling. Now what horizontal scaling is? Horizontal scaling. So what does it mean is it will you can create replica. You can create replica cluster. You can create replica cluster. Means you can create a multiple instance of a server, right? With a database server. Okay. Let's say you're having TV server one. Let's say TV server, and which is listening on port 27017. Okay. Now you're not you're getting heavy read data, and it is taking more time. So you can create a replica of same of a different server which is listening on a different port. Let's say 2007 27. So means we can create a multiple instance, right? Multiple kind of instance, you would say, or multiple, or replica. Yeah, you can do a sharding. What does sharding mean? I just explain you later point of time. What is sharding? Basically, we create collections, based on certain fields. Because let's say if you are having a, but yeah, we'll see later. Not now. It will become very lengthy video. We'll try to sum up. So let's say we learned about database. So if yeah, so basically it store data, or not store data. You can perform CRUD operation, create, read data, update data, delete data. Okay. And more while reading, you may can filter like what's the age will be and what's the name will be, email will be. You can just filter out. Okay. And inside this data we should have many different tables and different collections. So now if we have different collection, then how we can join this collection, this we should know. Okay. Now in a broader way, we have a SQL and NoSQL database. NoSQL, generally we see MySQL and PostgreSQL is very famous. In NoSQL we have MongoDB. So different we just learn this what is different between SQL, NoSQL, and in the use cases, like in which scenario we opt for the SQL and yeah, only the use cases. So basically, if you are designing a certain banking applications, that's Google banking application, banking banking application, or if it's like so many joins you need, so many joins you need, certain need between different table, so many relations, joins or relations you need. You have relations you have in a different tables, then you go for SQL. And what else? Okay. For NoSQL, it's like man, for e-commerce, for vlogging or anything like, except this banking application, you can use NoSQL. It's like very good, and you just need to have it and have it. Like you don't have so many joins, don't have so many relations, so many don't have so many relations, which is pretty forward. Okay, we have employees, that's we need to get employees and delete employees and update employees. That's it. Don't need that much joining. And what else we can do? Okay, don't have so many relations, e-commerce. Yeah, that's it. So yeah, thanks a lot. We will continue in a next video. Yeah.